Welcome to Maths and Science Unpacked. In our previous videos, we started looking at factorization, and we said that in our high school or secondary school level, we will encounter mainly three types of factorization. So I explained this in my previous video. We will encounter simple factorization, difference of two squares, and then quadratic factorization. I'll later on go on to quadratic factorization when we are looking at quadratic functions, and then we will explain how we handle quadratic equations or quadratic expressions. We have already done simple factorization. Please check out the previous video and follow the skills required to do simple factorization correctly. In this video, we want to look at another type of factorization based on what we call difference of two squares. Now, when we are doing an exam, in the anxious moment of trying to complete all the questions in the limited time given, we can get a bit confused about certain things. So, for instance, you could be given an expression 64 plus s. No, sorry. You could be given an expression 64 minus s squared, and you'll be asked to factorize. Okay. Now, in the anxious moments where you are trying to do more in a limited time, you begin to think factorization. When I had my lesson in maths on factorization, I was told to look out for common terms in the expressions, common factors. But here I have 64 and here I have s squared, and I've been asked to factorize this, but I can't see anything that is common to 64 and s squared. So what must be happening? So this is my advice to students. In any math exam, the moment you get the question factorize something, first of all, make a mental assessment and decide what kind of factorization could I possibly be doing, and then look out for the terms involved. First of all, see if you can readily find some common factors in the numbers involved in the terms or some common variables. If you can't do that, step back a bit and look at the terms again. Are they squares? Are they squares? And if they are squares, is it a difference? Is it minus? What we are going to do about difference of two squares does not apply to expressions where we have 64 plus s squared. You cannot use the method we are about to go through in this lesson to solve something like this. You can only use it to solve an expression where each term in the expression is a square. Okay, by a square, we mean that we can easily find the root of that square. Okay, if it is a number, we can easily find its roots. It's a variable like s squared, we can easily find its root as s. Okay, so that's the first thing you look. And then secondly, it must be a difference. Okay, in maths, difference simply means subtraction. Okay, so something subtracted from something. So for instance here, s squared subtracted from 64. Now, when you have an expression like that, then it's very easy to factorize, although you can't readily see common factors in them. So let's get a fresh page and see how we actually go about this. We call it the difference of two squares. I abbreviate it to be dots. Difference of two squares, dots. So we had 64 minus s squared. Now, when you have an expression like this and you have already gone through the two criteria that I showed just a minute ago, you then establish that the best way to proceed in factorizing this expression will be by using the method of difference of two squares. So in difference of two squares, what do? We will make two separate brackets to contain different expressions, and then we will look out for the roots of each of the terms in the expression. So the root of 64 is 8, okay? And here I will encourage you to at least know the roots or the squares of first 12 numbers, so that if you encounter them in a math problem, you can readily tell if they are a square. Okay, so the square of 1 is 1, the square of 2 is 4, 3, 9, 4, 16, and so on, all the way to at least 12, if possible at least to 15. Then you can easily identify squares in mathematical expressions, and then you can decide what way will be the best way to proceed in solving it. So here 8, so I put my 8, and then I put the root of s square is s, so I put my s here, I put my s here, and then all what I need to do is make one plus and make one minus. That is how difference of two squares work. Difference of two squares. Okay, so first you find the roots of each of the term in the expression. So let's list the procedure. 1, first, before you can use difference of two squares to solve that, establish that it is difference of two squares. We've talked about that already, but yeah, that is it. First, be sure that the expression you have been asked to factorize is a difference of two squares. When that is done, the next thing you need to do, number 2, is find the square root of each term in the expression. So once you find the square root of each of the term in the expression, then you will just basically proceed as I've taught you. So have two brackets. Each of the root stays in the two brackets as separate expressions, but one will be separated by a plus, another will be separated by a minus. Let us look at another example where we use difference of two squares. Difference of two squares to solve a factorization problem. So I have s square y square minus 49m squared. Okay, so this is an interesting one. How do we establish that this is difference of two squares? How do we establish that this is difference of two squares? First of all, each of the components in the terms are squares, so we can easily find their roots. Okay, now let's try and find the roots of each of the components in this. So here we have s to be the root of s squared, we have y to be the root of y squared, here we have 7 to be the root of 49, and then we have m. Okay, so all what we need to do is to have our two brackets, of course. This one, the root is sy, and here the root is 7m. So sy 7m. Just make one plus, make one minus. It really doesn't matter the order that you put it. You can decide to make your first bracket minus, and second, just make sure that you do plus and minus. Okay, now someone may ask, how then do we verify that this is correct? Because it looks so simple to believe. So let's take another very simple expression where we are looking at difference of two squares, and let's use that. So for instance, I have s squared minus y squared. Okay, this is a very simple expression. I will take another expression. Let me bring a blue team. I'll take another expression. I'll take 25 minus y squared. Okay, now let's use difference of two squares to solve this one separately. Then we will go and expand the brackets and see if we indeed get the same expression as we factorize. So first of all, here the root is s and y, so I'm simply going to get, oh no, this is the red team, so let me use the red. So I'm simply going to get s minus y, s plus y. As simple as that. I factorize that. Now let me go and do this one. This is going to be 5 minus y, because the root of 25 is 5. The root of y squared is y. And then 5 plus y. Now, let's go and expand the brackets and see if we end up getting the same expression. So now I know that subsequently we will be having another video that looks at binomial expansion. This is what we call binomial expansion. But let's quickly go through that. There will be a dedicated video looking at binomial expansion. But just to prove to you that this method is actually correct, this is going to be s squared. So this s goes for that, and then this s goes for that, sy. This one goes for that, minus sy. And this one goes for that, minus y squared. So as you can see, plus y plus sy minus sy is 0. So what we actually have then becomes s squared plus 0 minus y squared. Plus 0 is nothing, so we can remove that. So we actually end up getting s squared minus y squared. And so we are actually correct. Remember, I told you that the opposite of factorization is expansion. So when I factorized, I got this expression. When I expanded, I came back to what I factorized. So indeed, difference of two squares is a correct way of factorizing an expression that fits the criteria. Let's test with this one too. This time I'm going to use the black pen. So 5 times 5 is 25. 5 times y is plus 5y. Minus y times 5 is minus 5y. And minus y times plus y is minus y squared. 5y minus 5y is 0. So we have 25 plus 0 minus y squared. We can ignore the plus 0 because it doesn't add or take anything out from the expression. So then we get 25 minus y squared. So again, it's a correct way of factorizing an expression that fits the criteria. Both of the terms are squared, and then it is a difference. Okay, these are the two criteria. Once our expression fits this criteria, we can proceed and factorize it using the method of difference of two squares. So that is the other way we will factorize expression. Thank you, and join me again next time for another fantastic lesson as we make our journey through maths. Have a good day. Bye.